Now what I've done is I've just copied out the sketch then of what we're given. I've also put in the unit vectors I and j, and it's not drawn to scale because, I mean, if this is obviously 100 units up here, it's hardly 100 of these j's are going to fit through here, but hopefully you can appreciate then that I've not drawn it to scale. Now in the first part then we've got to find the speed of this hiker h who's walking with a velocity. Let's just mark it in that the velocity of the hiker, let's just go there, velocity of the hiker, I'll underline it because it's a vector, is given as 1.2 I minus 0.9 j. And what does this mean? Well, essentially it means that our hiker h is moving along here 1.2 units for every 0.9 that goes downwards. So it's not again drawn to scale, but the hiker then is moving in this direction with this velocity v. And if we just mark on here that this represents 1.2 units, this is 0.9 units. And if we're to get the speed of h, then we need to find out the magnitude, the length of this line. So we can do that by Pythagoras' theorem. The speed of h, let's just put it down here, okay, equals the magnitude of the velocity vector, which is going to be equal to the square roots then of the sum of the squares of the components. That's 1.2 squared plus 0.9 squared. Work that out, and what you find is that you get 1.5 meters per second. Okay, so that brings us to the end of the first part then of this question.